A thin sheet of ice is in the shape of a circle. If the ice is melting such that the area of the sheet is decreasing at a rate of 0.3 meters squared per second, at what rate is the radius decreasing when the area of the sheet is 17 meters squared? So let's draw a quick diagram. So this is the piece of ice. It says it's in the shape of a circle. And the question gives us the area. So using the formula of a circle, area equals pi r squared, we could find the radius. So if we rearrange for r, we'll get r equals area over pi, all square rooted. So r equals root 17 over pi. And if you work that out on your calculator, you'll get 2.32 meters. So let's mark that down. 2.32. So in the question, the area is decreasing at a rate of 0.3 meters squared per second. So this is the rate the area is decreasing. So dA over dt equals 0.3. Now, since the question said it was decreasing, we must put a negative in front of the 0.3. The way I knew it was dA over dt is from the units. So it's going to be a unit of area over a unit of time, so meters squared per second. So to solve this, we're going to use the formula for the area of a circle. So A equals pi r squared. We're going to differentiate with respect to time on both sides. And we're going to get dA over dt equals 2 pi r dr over dt. So we have dA over dt, we have the radius, so all that's left to solve is dr over dt. Now once we isolate for dr over dt, we're going to get dr over dt equals dA over dt all divided by 2 pi r. So that would be negative 0.3 over 2 pi 2.32. So if you plug that all in, you'll get negative 0.02, and that's dr over dt. So it makes sense that the final answer is negative because it says the radius is decreasing. A square picture is 520 by 520 pixels. The picture is being resized such that the area of the square is decreasing at a rate of 25 pixels squared per second. When the picture is 300 pixels wide, what rate is the height decreasing? So let's draw a quick diagram of the picture. So the question says it's 520 by 520. And we could label this X and Y. So the question gives us the rate that the area is changing. So dA over dt equals negative 25. The negative is because it's decreasing. Now it's asking the rate the height is decreasing when the picture is 300 pixels wide. So let's draw that. And we're looking for dy over dt because y is the height. Now we could use the formula for a square, which is area equals x times y. And since it's a square, x will be y, so y times y is y squared. Now if we differentiate with respect to time on both sides, we'll be left with dA over dt equals 2y dy over dt. Now we can isolate for dy over dt, and we'll get dA over dt divided by 2y. And if you plug that in, you'll get negative 0.042. And that's dy over dt, and that's our final answer. Two cars leave a parking lot at the same time. One car travels north at 65 kilometers per hour, the other travels west at 50 kilometers an hour. How fast is the distance between the cars changing 2 hours later? So car A and car B start at this point. So let's just label that. And from the question, let's say car B goes north at 65 kilometers per hour, and car A travels west at 50 kilometers an hour. So let's just label that. And the question's asking how fast the distance between them is changing 2 hours later. So let's draw the diagram a bit bigger, and we can see it's in the shape of a triangle. We'll just label X, Y, Z. So this is car A and this is car B. And car A's speed is 50 kilometers per hour, so we could label that as dx over dt equals 50. And car B's speed is 65 kilometers an hour, so that would be dy over dt equals 65, because that's how fast side length y is changing. Now the question's asking for dz over dt 2 hours later. So from the formula distance equals velocity times time, we could see that 50 kilometers per hour for 2 hours, that'll be 100 kilometers. And if we do the same thing for car B, we're going to get 65 times 2, which is 130 kilometers. Now we could label that here, so 100 and 130. And now we could find side length z, so z equals root 100 squared plus 130 squared. Now if you plug that in, you'll get 164. So we could label that as well. Now we could set up Pythagoras. And we're going to differentiate with respect to time because we're looking for dz over dt. So 2x dx over dt plus 2y dy over dt. Now if we rearrange for dz over dt, we're going to get 2x dx over dt plus 2y dy over dt divided by 2z. So if you plug that all in, you'll be left with 82 kilometers per hour. And that's your final answer.